Class 9 Number Systems Module 4 Objectives. In this module, you will learn about operations on real numbers. Dear children, last class we have studied what is a real number. Yes, what is that? A collection of rational and irrational numbers are called real numbers. And we know two type of rational numbers. First one is terminating rational number. Second one is non-terminating repeating rational number. Now, what about irrational number? The decimal form of an irrational number is what? Non-terminating, non-repeating. Now, listen carefully these questions. Check whether 7 root 5, 7 by root 5, root 2 plus 21, pi minus 2 are irrational numbers or not. We need to check whether these are irrational or not. Now, given the values of root 5 is equal to 2.236 etc. Root 2 is equal to 1.4142 etc. Pi value 3.1415 etc. So, all these are what? Irrational that we know. Now, consider 7 root 5. So, 7 root 5 means what? 7 into root 5 value we need to substitute. That is 15.652 etc. Now, when we find out the product, listen carefully. It is also what? Non-terminating, non-repeating. That means it is an irrational number. Next one, what? 7 by root 5. So, the division by an irrational number is too difficult. So, to avoid that, since the denominator is irrational root 5, we need to change that into rational. So, we multiply denominator root 5 into root 5. So, when we multiply the denominator only by root 5, the expression is changed. So, we need to multiply numerator also with which one? Root 5. So, 7 by root 5 into root 5 by root 5 become what? 7 root 5 by 5. So, 7 root 5 value is what? 15.625 etc. etc. is important. By 5 it is equal to what? 3.1304 etc. Now, listen carefully. Here first one 7 into root 5. Then second one is what? 7 by root 5. Next one what? Root 2. So, root 2 value is given. We know root 2 is an irrational. So, root 2 plus 21. So, 1.4142. An irrational plus 21 is what? 22.4142 etc. is also irrational. Last, pi minus 2. So, 3.1415 etc. is the pi value. Minus 2 is equal to 1.1415 etc. All these are non-terminating, non-recurring decimals or non-repeating decimals. So, all these are what type of numbers? Irrational numbers. Clear? Now, listen carefully. Simplification. Important one and also simple. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So, listen carefully. Here we need to add it. So, the like terms we can add it or subtract it. Okay, so we can write the first expression as 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. Now, listen carefully. The like terms we can write it together. So, 2 root 2 plus root 2 plus 5 root 3 minus 3 root 3. Then that become what? 2 root 2 plus 1 root 2 is what? 2 plus 1 into root 2. Take root 2 as a common. Then next plus 5 minus 3 into root 3. Take it as common. Then 2 plus 1 is what? 3 root 2 plus 5 minus 3 what? 2 root 3. Clear? Now next multiply 6 root 5 by 2 root 2 root 5. Sorry. Then solution. 6 root 5 into 2 root 5 is equal to 6 into 2. Then after that what? Root 5 into root 5. Now 6 into 2 what we know that what? 12. Then root 5 into root 5 is what? 5. That is root 5 into root 5 is root 25 which is equal to 5. is equal to what? 12 into 5, 60. Now, when you find multiply two rational numbers, sometimes the product is what? A rational become. Okay. Divide 8 root 15 by 2 root 3. So 8 root 15 divided by 2 root 3 is equal to 8 into root 15 can be split as root 3 into root 5 by 2 root 3. Now we can cancel root 3 and root 3. Then 8 by 2 is equal to what? 4. 4 root 5. Okay. So listen carefully. From all these examples, we can conclude some properties. First one. The sum or difference of a rational numbers and an irrational numbers is irrational. That is the examples are here. Okay. Now the product or quotient of a non-zero rational number with an irrational number is irrational. Product or quotient is also what? Irrational. Now if we add, subtract, multiply or divide two irrationals, the result may be rational or irrational. Maybe rational example is what? That third one, 60 is that product. Okay, a rare case, sorry. Okay, now listen next, some identities. We know different identities that we have studied in the lower classes. So listen carefully here, the identities. For positive real numbers a and b, the following identities hold. Root a into b is equal to root a into root b. Then b, second one, root a by b is what? Root a by root b. The next, root a plus root b into root a minus root b. A plus b into a minus b, what? A square minus b square. When we apply it, root a square minus root b square. Root a square is what? A minus root b square is b. Next, a plus root b into a minus root b. Same applied. So a square minus root b square is what? B. Then next, root a plus root b the whole square. That is what we can apply. Which identity? A plus b the whole square. So root a square is what? A plus 2 into root a into root b. That is 2 root a b plus root b square. What is that? B. Next one, root a plus root b into root c plus root d. So just multiply a plus b into c plus d like that. So root a into root c become root a c plus root a d plus root b c plus root b d. So we can use these identities for calculating some problems. Now listen the simplification. Simplify the following expression using above identities. So 5 plus root 7 into 2 plus root 5. A plus b into c plus d. When we apply it, what? First 5 into 2, 10 plus 5 into root 5 plus 2 into root 7 plus root 7 into root 5, root 35. Now listen, here no like terms are there, keep that answer in that way itself. Next, 5 plus root 5 into 5 minus root 5. So a plus b into a minus b we can apply. That is what? 5 square minus root 5 square. So 5 square, 25 minus root 5 square, 5 is equal to what? 20. Now third one, root 3 plus root 7 the whole square. We can apply which one? A plus b the whole square. So a square root 3 square plus 2ab, 2 into root 3 into root 7 plus root 7 the whole square. Root 3 square what? 3 plus 2 root 21 plus root 7 square 7. Now add 7 plus 3 is what? 10 plus 2 root 21. Now the next problem, listen. Root 11 minus root 7 into root 11 plus root 7. A plus b into a minus b, which is equal to what? A square minus b square. That is root 11 square minus root 7 square, which is 11 minus 7 is what? 4. Okay. Now simple question. Next one also the same. 3 plus root 3 into 2 plus root 2. A plus b into c plus d you can apply. So 3 into 2, 6 plus 3 into root 2, 3 root 2 plus 2 into root 3 plus root 3 into root 2 is what? Root 6. Now like terms are there, keep it in that way. Now the next type of question, one more question. Recall Pi is defined as the ratio of the circumference of the circle to its diameter. So we know the circumference is equal to pi into d, or what is 2 pi r. Twice of radius is diameter. So pi is equal to what? C by d. This seems to contradict the fact that pi is irrational. So listen carefully. Here pi is what? C by d means we can represent it as in the form p by q. But we know pi is irrational. This seems to contradict the fact that pi is irrational. How will you resolve this contradiction? That is the question. Now listen. Pi is equal to what? Circumference by diameter. Is a rational number when C and B both are rational numbers. If C and D are rational numbers, we can say that what? C by D is equal to pi is a rational number. But the C, circumference and diameter, we calculate is not exactly a rational number, and either C or D or both both can be irrational numbers. Since rational by irrational, so the division of a rational and irrational is irrational, we can conclude pi is also irrational. Clear, students? Okay, thank you.